Cool. Uh, so as I was saying, this for compiling a program, because what we did is to just do the query stuff. To compile a program, you need to be able to go through read mode and write mode. Um, and as with queries, actual location precedes the translation of the textual form of a program term into a machine instruction sequence. And this is the opposite. I think this is it, right, Marinho? This is where we swap the order. Because in compiling
Uh,
queries, this is the last piece. In compiling programs, this is the first one. Yeah, I think it's saying in here. Marinho, are you there?
yes, that is in fact correct. Um, yeah, because we assume that the query already exists, right?
Yeah. The situation is reversed because query data from the heap are assumed available, even if only in the form of unbound ref cells. Hence, a program's flattened form follows a top-down order. So it's gonna be this is the exact reverse way of doing things in comparison to the previous session, the previous chapter thing. Uh, where is it? Well, it is somewhere in the book. Anyway, so now the flattened form of a program is tokenized for left to right processing and generates three kinds of machine instructions depending on whether is met. Okay, so these are the three instructions that we're gonna try to implement today, and they are way harder to implement. Get structure, unify variable, and unify value, and they are harder because they need pseudocode to be in the book instead of 4 lines of pseudo code. But what is convenient is that it's kind of thinking in OCaml terms. That's very convenient. That's very convenient. So that's what we're going to implement today. So let's read what
Mm,
these functions are supposed to do. So the first one, a register associated with a structure functor. Okay. A first sing register argument or an already sing register argument. So these is the three kinds of machine instructions depending whether is met. So these are the conditions. And these are the things. So we haven't read what these instructions do.
get structure. The other is unify variable, and the other is unify value.
Yes. Yes. Oh, okay. So there is a deref operation. Are we gonna use that somewhere?
I think we are actually. Um,
Sure, but where? Where are we gonna use the deref operation? Oh, here. Okay, so we need to implement this one first. Okay, so what this function is supposed to do? It's supposed to pick an address and return a new one. I'm gonna assume this is the syntax. I'm gonna eyeball it that this is the syntax. Then what we do? We grab the address. Store. What is a store?
the store is basically the entire memory. It includes the heap as well as the other regions that we haven't implemented
Ooh,
yet.
so we need to buy the computer memory. That brings an interesting question. Are we going to model the heap as an internal piece of an outer memory, or are we going to make them completely separate? Very interesting
We
question.
need to make them the same unless we change how we address values in memory.
I see. I see.
Otherwise, if you just have an address, how do you know which part of memory that address belongs to?
Okay, so assuming that this the store uh, is the memory, what are we doing? We're grabbing something out of the memory, which contains a tag and a value. So the memory is composed out of cells, right, Marin?
Yes.
And then we check if the tag is ref and the value isn't a, which is kind of weird because value is something and a is a pointer, is an address. Why are we checking for that?
Basically, we are checking if the variable is unbound, right? Because
Ah, okay, makes sense.
yeah, if the variable points to itself, that's the convention for an unbound variable. So you check if the value is equal to the address that you just dereferenced.
So we are looking for the first unbound ref in this deref function.
Basically,
Because I
yes.
noticed that if this is checking for not unbound, we are doing recursion on it. So that means that we are looking for the first unbound cell in the in memory, starting from the address as a starting point. That's what we're doing here. Okay, so then comes the question: how should we make the store?
Actually, that's not necessarily true because the condition may fail as well if the tag is not ref.
Oh, that is true. That is true. That is true. So it is either the first. Uh,
Like if it's a variable and it's bound, we recursively dereference it until we reach something that fails those one of those two conditions at least.
yes, yes. So that's the first question. How should we model the store? I'm very curious. How should we do that?
Uh, well, if we are following the model for memory that we already established, it should be the same as the heap, right? Because the heap is just a section of the store.
No, yeah, but are we doing this?
Basically, yeah.
Okay, so replace string heap with the store. But it also changed the other thing. And there is a way, there is a shortcut to not do that, but I keep forgetting. Do you know, Magetta?
Shortcut for what?
To when you're doing replace string in Emacs,
Mm-hmm.
if you just do it normally, it will replace the ones with capitalized things and non-capitalized things. And I would like to only do the non-capitalized ones.
Uh, if you're using the function that does the rejects, you can just put the capitalized and it should pick only capital.
Oh, okay, we're using the rejects one. I see, I see, I see. Okay, so the heap is now. Hmm. I have a question to you, Marin. So when we say heap zero, are we saying that there is an internal indexing just for the heap, or the indexing works if I just say store instead of heap?
Well, the heap means it's in the store, but it's specifically in the part of the store that contains the heap.
Yeah,
You
but
see?
is there such a thing as a heap zero being different than store zero?
Well, yes, because the heap, um, if you go back to, there's a diagram somewhere earlier in the book containing the memory layout of the machine.
Wait, not this one then. Are you sure? Yeah, I think it
I'm
is this image that I already. That's a problem, dude. Are you talking about this one?
no, I'm not actually.
Oh, so it's in later pages.
Yeah.
But
Actually, that might have been in the other paper I was reading, the original paper by Warren himself, you know.
ah,
Uh, because I took a look at that as well, and it's not nearly as clear as the one book. Um, but it did go like right into it. So
yeah, but do you see the problem? If store
uh,
zero is different than heap zero, we're gonna have to have a reference on where the heap starts within the store,
well, yes.
and that sucks. Um, okay, so in that case, let's say heap threshold.
Now you know my feelings about stacks that are not actually implemented in the processor.
Um, okay, we're gonna have to have that's I don't remember. That's not the syntax. Yeah, that's definitely not the
This
syntax. This is the
tutorial,
syntax. So this is heap. Magenta, are you
organization.
following the problem here?
Yeah, I am.
Okay.
At what cost? I don't know, but I am.
So the problem is, uh, whenever we are doing heap stuff, the indexing that we are doing, like store something and heap something, although one is within the other, the indexing of them is completely different.
Mm-hmm.
So heap 0 is not the same as store 0. So
It's
it's not an alias, just for explanation and pictorial purposes. The
actually, if you look at, there's actually an explanation of that notation. If you go down to page, where is it? Page 16 of 129.
that's not. Oh, 16
That's the
here.
one. Yeah, that's the one.
Yeah, talking
Uh,
about this one here, right?
yeah, we shall use the generic notation store of n,
To
store
remove the
sub
contents
a,
of
actually.
term data cell at address A. We shall use specific area notation whenever you want to emphasize that address A must necessarily lie within that area. So that sucks because that means now
Well, no,
that
the
I need.
addresses are, they are aliases. It's just when you see heap, that means, oh, okay, the address must be within a certain sub-range of the entire store.
Wait, then that completely changes again my understanding. I'm gonna ask it, try to ask it again differently. When you say store 0 and heap 0, are that is that gonna be the same value?
Uh, they are assuming that the heap actually starts at address 0 in the store. If it doesn't, then one of them is actually undefined.
Okay, let's assume that they are then. Let's assume that they are. So the difference is only what you said before, which is um, um, the difference is that when you're saying heap specifically, you are just saying that this index is within some boundaries and
Yeah,
the of the heap of
yes,
the heap.
because the heap is not the entire store. So when you see heap square brackets a, that means, okay, a must be within the heap. If it's outside of the heap, then we have a problem.
Yeah, yeah. So basically, I'm gonna save the heap size as well, but this should not change that to should not change the implementation of anything. And there should be a to-do checking. That's gonna be really hell of annoying. We need to check the heap size every time we're doing manipulations with the heap then. To check
Do we?
if the index of the register that we are using is within this guy. Because you may try to do this thing passing 0 to the heap size, and that should blow up.
Mm-hmm.
That should blow up. Okay, so with that out of the way, let's implement dref. So let's make that. Let dref. And what are the arguments of this guy? Here. So you get an address, which in our case is just an integer, and you return a new address.
Funny enough, that algorithm is actually also the same one used for reading the results of a composable promise.
That is interesting. I didn't know that. Okay, so I need Mageta's wisdom now. Do you know the syntax to destructure a record, but also have an alias for it?
Yeah, you just deconstruct
Yes.
the thing as you normally would, and then do puni with an S.
Oh, so
It
as like
sounded
this.
yes. Oh, but that needs to be between parentheses if you're gonna put the S. That sounds
Oops.
bad, actually.
It did. It actually did sound bad. Is this the syntax?
Yeah.
Okay. And we should do the same with the other guys as well. I'm not gonna do it right now though. Okay, so what should we do? We should do a lookup. We should do a lookup. And how do we do a lookup? I already forgot how to do that. Uh, how? Oh, find. This is how you do it. No, no, that's for
That's
the
no,
map. That's for the
yeah,
map.
no. That's for the map. Yeah,
How are we?
there's
But we have to do that. We have to do that, right? Before. Yes, we are doing the set variable. So how are we doing that?
mm, okay, set variable. Let's see. Reference store age
I think
register.
it's this line. I think it's 66, right? So we are grabbing what is stored in there. Well, the new store, right? Because this is basically just doing the other thing. And maybe I should swap
No,
the
actually, we're
names.
not doing a read there because it's not strictly necessary. Like,
Oh, that's right. Right? We decided to jump this step, right? Or something.
no,
Yeah,
we're
pick
basically saying
this
is
and put directly in here.
yeah. Um,
That's how we did it.
we are reading in put structure, I think.
Put structure.
Are
Sure
we?
about that? Are you sure?
Heap put
I'm starting to think that we
structure.
aren't. I think we did the same trick. We picked this and swapped in here.
Yeah, probably. Well, go to the heap module definition. There should be.
So there is a push and there is a pop. There is no get.
Well, we need a get.
Okay, so what is the thing again? So bet here.
You do know you can use the LSP, right?
Oh, the documentation here is not trash, right? That's right. Let's try that. Get ft. Okay, but there
It'd
is
be
the
faster to have both company mode and core full.
every time
That is
every time I get a complaint about that.
You should just fix your configuration, Lemus.
I
Company
mean, it's
mode is
literally
a
just
must if you're doing
removing a
Haskell,
line.
man. Fulcro sucks. Fulcro no. What's the name of the other one? The get.
Corfu?
Corfu. Yes, that one. Returns
Core full.
the ith element of t. But
Yes, that's exactly what we want.
but isn't this like unsafe as fuck? Well, I don't know if you care about that. So let's.
Actually, we need, yeah, ideally we should get the one that returns an option, no? We don't want to do an
I didn't
exception
see
handling.
any that seemed. Oh, it bugged. Try start typing again. Yeah. Now delete. What?
Corfu.
Okay.
Better than company, apparently.
It is actually, but
For
not
Haskell,
sure
it's
what's
trash.
happening there.
I can tell you that much. Okay, do I need to remove the entire thing? Yeah, I need to remove
Oh,
the
it
entire thing.
worked.
Okay, so we need a get that is safe. So that's
Uh,
not what we want.
keep going. Although I think get opt would have been that one. Oh, maybe they prefer to do a exception.
Okay, so we're gonna have to handle that ourselves.
We could write a safe version of get that just handles the exception, right?
We totally
Yeah,
can
we
do
can
that.
overload the library.
We totally can do that.
Oh,
Actually, it doesn't need to overload the library. We just implemented it in the heap module.
that's what I meant. Just
Oh,
making a ft blah blah.
I thought you meant something else. Sorry then. So we're gonna do that, and we're gonna get a cell. So let's say, and I think it's also to do better to do that. So it's gonna
Is this
be heap get, and I already forgot the syntax, but I'm gonna assume it's this thing and this thing in, and then we need to do a thing. So I think OCaml is match, right?
To do what? To pattern
Pattern match,
match?
yeah, pattern match on it.
Yes.
Match off. I believe that's the
No, it's
syntax.
with.
With, right?
Mhm.
I'm getting confused with the case. Okay, so if this is, we only care if it's a reference, and the reference holds a value. I don't remember. It does hold a value. Okay, cool.
yes?
So there is an ADDR here, and then everything else we don't care. Actually, this should be a fail with. No, it shouldn't be a fail with actually. because we're gonna just do the thing. So if there is nothing in there, we're gonna return A out of this thing, which reminds me that we need to do this thing, and then we're gonna do dref dref a computer er. There we go. There we go. And what is the problem here? The following labels are not bound. Yeah, I know. So
What?
Either bind these labels explicitly or add semicolon underscore to
Oh yeah,
the
add semicolon to discard the rest.
like this?
Hmm.
underscore. Yeah.
Okay. So this is the dref function. Easy enough. So now that we have that, we can go and do get structure. So get structure. We should receive a functor, which I don't remember. Are we?
But functor is a keyword, no?
Yes,
Functor is a
it's
keyword.
yeah.
Let's
Um,
put. I don't know.
you can put or you can put functor and then a prime,
Uh,
like a quote, like functor quote.
functor this.
Yeah,
And I have a
that works.
question. I don't remember. Do we need to say that this is a cell instead of a specific functor? We need to do it like this, right? Say that this is this thing. And we also have the index of the register. Index of register. Let's go. And what? And the computer, of course. What is the best way to indent this? Do you know, Magata? In F Sharp, I remember doing things like this.
What?
Is that how you do that?
Uh, yeah. There's no problem with that.
Okay. So what do we gonna need from this guy? We're gonna need the store. Um, we're gonna need the H. We're gonna need the mode. Are we reading the mode actually? We aren't. So screw you. Do we need the registers? No. And so that's it actually. Let's say computer. That's not how you do that. This is not closure. Uh, and we're gonna return
Uh,
the computer.
do we have an implementation of that bind function already?
Well, what is the implementation of bind? That is not
I think
here.
it might be on the next page, maybe.
Imagine that being worse for a moment. Oh, this is unification.
Let's unify. There's no bind. Oh no, actually, the bind that we need to use here is pretty much trivial. But they use the name bind because the implementation of that will change as the book progresses. But
Yeah,
that's
but what is
basically
the
just
implementation?
um, it's in the paragraph on page 17, right above the yeah, right above that. Yes,
In the
that
definition of
paragraph.
get structure, we write bind to effectuate the binding of the heap cell rather than this. So this is just syntax sugar for now of this.
For now, but later it will mean something else. Yes,
Cool.
as we get more features in the machine.
That's okay. So the first thing that we need to do is call the ref. So we're gonna have that thing there, and we're gonna call the ref passing the index of register, and we need to pass the computer.
Let me go eat some garbage. I'll be right back.
Sure. Next up, we do the match. So match. Okay, that's a little bit unfortunate, but we need to do the case on the store of the address there. So that's gonna be heap get store, and we are using this guy with. Okay, that's very cool. That's very freaking cool. So there are only two things. Well, there are three things that we can match, right? We can match a structure. Yes, we can match a reference. Uh, and we also put a functor there. Oh, that is correct. That is correct. But we don't care about these two, right, Marin?
Right.
Okay. So let's go here and say, let's start with the reference one. So reference, and I need to swap the switch of backspace. But okay. And we actually don't care about the other thing. So what are we gonna do? Do we have blocks in OCaml? How does that work? Do you know?
I'm not sure,
I
actually.
have no recollection of the syntax at all. I'm gonna assume it's just space sensitive because Emacs is kind of telling me it is. Um, so we need to get the new heap. So heap, we're gonna do heap put. Uh, yeah, okay. And then I don't remember what is the type. What are the types? So we pass the value first. The value will need to be that thing there. So structure h register plus one in. Then we're gonna put the structure in here using h register, and we're gonna pass the store to that. Then, okay, this is actually one of the those cases where we can use the thing. So heap put, and then the value that you're gonna put is the functor thingy. Do you prefer that inlined, or do you want me to create a label for that?
Uh,
I think it's fine to create a label.
Either way works.
Uh,
I don't I don't have a particularly strong preference.
yeah. Actually, I'm gonna inline it because we are getting out of names, fundamentally. So functor prime.
Concatenative programming for the win.
And
Well, it's
then
not
I just...
concatenative actually, but the idea is the same.
Um, and then we need to pass an integer to that, which is gonna be h register plus 1. And I just noticed that functor is complaining about shit. The constructor functor expects two arguments, but here is applied to only one of them. Oh, you need to deconstruct the shit.
Right, because we actually get a pair, not a.
So I'm gonna assume that I can just do this and pattern match immediately here. So this is gonna be f label and f index.
It's not really an index, it's the arity of the
Arity.
functor.
That makes sense. I was kind of forgetting what the number was. Okay. I remember that we did this already before. Oh, here, dude. Okay, we can actually now label that stuff. Well, let's also use the full names to to be consistent with the other guys there. Func. I don't need these anymore. Func. And that's pretty much it, right? That's pretty much it. We did the stuff. And actually, there will be another thing because we are also doing a heap put because this is just syntax sugar, right? And I also think we jumped a few steps. What is the get structure supposed to do? It's supposed to retrieve the structure out of an address?
Well, it depends on the mode,
No, but
but
we're not doing that in checking the mode here.
yeah, it's supposed to retrieve the structure, indeed.
That makes sense.
And
Let's
where
make
is?
a reference, and let's say that this reference is using the H register in. We're gonna put
Oh,
reference.
actually, get structure is not mode sensitive. It's the one that sets the mode for the other two.
Yes, I noticed that. I noticed that. So this is our final heap. This is our final heap. So what is this function doing? This function is grabbing a functor and a register. We are not using the, oh no, we are dereferencing the register. So we are trying to find the first bound variable or a functor, right? Or yeah, or an empty cell.
Yeah.
Okay. And then we are using that as an address to check. Okay, so fundamentally what we're doing, if you go up
Actually,
all the
we're
way up,
looking for the first, either the first free variable or the first non-variable. Like if the variable is bound, we just dereference it and look at what it's pointing to.
but what if you reach this thing?
Then we will see that actually the address is equal to the contents and we just return it.
But that's not what we're doing in the deref function.
But it actually is.
It isn't.
Oh, you're missing the side condition in there.
Ah, okay, so I'm very glad we did a backup, like a few steps back. Yeah, there is an if. Okay, so how do you do guards in OCaml? Okay, guards. Okay, so it's with the when. That's cool. Can I combine those things? Yes, I can combine those things. So when, and then there's something called a value, right? There's something called a value. So we can also, by the way, I believe we can
Uh,
do the thing.
we're already checking if it's a reference in the pattern match. So actually we only need to check if the address that we got from the reference is equal to A. Actually, if it's different from A.
That makes sense to me. Oh no, that you are completely correct. I don't need to do this thing here. It's just checking if. Okay, let's actually to follow the book. Value, and it needs to be different. How the heck do you do that in OCaml? Is it like this? A. I have no recollection actually. I'm gonna assume it is. I have a kind of intuition from F sharp that it is.
Let's see, OCaml operators.
I'm gonna assume it is. I'm kind of confident it is. Okay, so let's go back to the image. We are looking, as you said, we are looking to the in the get structure function. We are looking at this piece of memory here and looking at the first available cell.
Uh,
That is not true though. If there is a functor there, we also stop. Or a structure. Agree on that?
yeah.
So, but here's the problem. We are looking for a structure, but we might find functor or empty. What should we do in those cases?
Um,
I think that is written in the code then. Let's check. Here. So if I find a reference that is bounded, right?
yeah.
Yeah, this is missing the functor case. An empty case for that matter.
No, it's not because the default case is to fail.
Oh, here. What the heck is this syntax?
Well, apparently we need a flag, a Boolean flag, freaking Boolean in the computer.
Okay, we actually don't need that because we can just extend the mode thing. What do you think?
Um, I'm not sure
And
actually.
do failed. And then in the execution loop, that's going to be calling all of these functions. We
I'm
check
not
if it
sure
failed.
actually, because we may need to remember the mode even across failures.
Ah, I see. Okay, so for now, let's just do a fail with, because, well, it is what it is. Rather, what do you recommend for us to do in this case?
It's kind of tough.
It's kind of tough.
The choice is between a boolean or throwing an exception. It's not great, to be honest.
Is this how you do Boolean stuff? I have no recollection. Yeah, that's gonna
I
be annoying as fuck. Let's just do a fail with for now because we're gonna have to change everybody else. We need to change the syntax of these guys to not use this structuring thingy and do the way that we are doing now from now on. Anyway, so now what we're gonna do? This thing we don't mutate stuff, so this is gonna be in the return of the new computer
yeah.
and the mode as well. So that basically means how do you update a record in OCaml? That's the real question. So records OCaml. Let's go to records OCaml.
Records and tuples. Tuples.
Okay, but how do you update stuff? I don't want any of this. Just want a very simple example, dude. Like, come on. Don't be jerks. Just tell me the thing. The internet is kind of bad. Records OCaml. Okay. How do you update it? I understand that. I also understand that. We can access a field by doing so.
Okay, to construct a new record with some field values changed without typing in the unchanged fields, we can use record update syntax as shown. Um, Basically, you do a curly brace, you use the previous record, and then you say with, and then
Oh,
you
okay.
put
So
in the
okay, I see. So you're basically saying computer
with,
with
and then you put the fields
h
that you want to change. Yeah,
register is gonna be h register plus true. I'm gonna assume it's semicolon. Mode
it is
is
semicolon. Yes.
write. And 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 again, we go to the same problem of how do you, yeah, maybe that's how you do that. And then I'm gonna say store is equal to the heap. And that's how you return the new record. So it's also complaining about the pattern match not being exhaustive. Thank you very much. Let's go back to the book. And now we're gonna do structure stuff. So structure. And there is a value in here. Yes, there is a value. And you're calling that A. Uh,
Oh, I see. That's kind of nice because if we get a reference after we look at the store at the address, we know that it's a free variable because we did the deref earlier. I see.
Wait, repeat the insight, please.
No, it's just if you get a reference after getting the store value at the address
Yes.
after the dereference,
Yes.
because of the semantics of deref, we know that that variable is unbound, right?
Yes.
So we bind it.
Yes. Actually, yes. Okay, so in the case of the struct, I think we need to retrieve stuff from the heap. So we're gonna do a match. We're gonna do a match. And we're gonna do with. And what are we gonna match? We're gonna match heap get, and the get, you pass the store, and you pass the thing, you pass the thing, and
Hello,
then
Nathan.
what should it be? It needs to be a functor, right? Functor in which the first guy is a string and the second one is a number. So functor label. Oh,
Specifically, it needs to be the same string and number that we got as arguments.
yeah, but as far as I don't know if there is a cool like idiomatic way of doing so in the thing. I'm gonna just oops. I'm just gonna call this label and arity. And probably there is a nicer syntax way of doing it, but I'm gonna do just this. So label,
Okay.
uh, and here's the thing: is the equality this? Also don't remember. Functor label, and I also don't remember. I think it's this. Arity equals functor arity.
We're doing some OCaml, Nathan.
So this thing here. Then, if that's the case, if that's the case, we're just gonna say, what the heck is S? Do you know?
S. Which
Well,
S?
this one. That sounded bad.
Um, that's probably a register name, maybe.
That sucks. We're going because man, let's redo the other functions because this is getting out of hand. Let's redo the other things. So as computer. Oh, that's this is not the syntax to do that. This is not the syntax to do that. So we are using register. We are using store. We are using hregister. But we are not using the mode and all the nonsense. Yeah, let's fix this. Let's fix this first because it's hell of annoying. So this thing, and then we do that, and then we're gonna do the syntax that you showed me. So this with, and probably
Mm,
you can use equals instead of as there. Ah, okay, I prefer as to be honest. Oh, to rename the fields you are matching. Oh, but we don't want to rename them. We definitely don't want to rename them. And I just noticed that this is reversed. This needs to be this, and this needs to be that. Awesome. Man, imagine, does this syntax work? Do you think it works, Marinho? You know what I'm doing there? Do you see?
Uh,
I don't know if that works. Does
computer
that work?
with
Or do I need to do store equals store, stuff equals stuff? Punning works. What?
punning.
Punning works. So I'm gonna assume that we are okay then. And if it doesn't work, it is all Nathan's fault. Boom, boom, boom. Computer. And then we're just gonna say computer with that stuff. That is cool. That is cool. I have another question to you, Nathan. You see this thing here? What will happen if I put functor label in here and functor arity in here? That's not gonna work, right?
not elixir. Right, because defining a variable on the beam is actually a very simple unification. I mean, you can do the same thing in Erlang as well.
Yeah, so it doesn't work, right? That doesn't work. Okay, that's very fucking sad, but okay. I accept the reality. Um, so let me finish the thing here. So parentheses there, boom, 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 as computer, boom, boom, computer with. Okay, okay, so now let's add the S register. And while we are at it, let's also add the boolean. Because I just said that we would do it if we had the other syntax. Okay, so now
How
let's
do
go
you
back here.
rename fields in Erlang?
Computer with. We never use that. If it is available to rename the fields, I have no idea how you should do that. SC register equals a
I'm pretty sure you have to be explicit about that in Erlang, actually.
and mode equals read. Boom. So that's kind of it. And then otherwise, look how beautiful actually. Look, Marin. This is very beautiful, man. Not gonna lie. Look at that.
Fail
This
equals false.
No, it's actually the opposite. I thought of another thing. So that's not actually what I want. Yeah, thank you very much. And then we also gonna say the computer is broken, friend. The computer is fucking broken. So this match is not exhaustive. It's still not exhaustive. How? Very good question. We should need to discover what the heck is the S. Fail false.
Probably a register, but let me check the original paper actually. That
I'm not
might
talking
be
about
this.
OCaml necessarily, Nathan. This would be just as beautiful as in Haskell. I'm talking about that all of these things, they all collapse into a single thing. And that's very, very nice. Very fucking nice. So how is this not exhaustive? I don't understand. I really don't understand. Which pattern matching I'm missing, Marinho?
Um,
Like what the fuck? What? It's complaining that an example that is not matched, empty and all that stuff. But this is the thing. This pattern match is unexhausted. Here's an example of cases unused that is not matched. Yeah, but this is a catch-all thing. How does that make any freaking sense? And it is aligned. What the fuck? Parentheses, according to Okemo said. But where?
oh, you need to put parentheses inside of the inner match, I think.
You do mean inside this one? Fuck me! Okay, that was very unexpected though. Very fucking unexpected. But it is we did the function. We did the function.
I mean, I would have probably written this with the parentheses to begin with because of muscle memory,
Yeah,
but
but that's not how you should do stuff. Unify variable. So we're gonna receive an index of register What should this function do, Marinho? Unify variable.
Unify variable depends on the mode actually.
Okay, so if it's in the read mode, we are putting a heap. Let's also read. What the heck is the S register?
Uh, Register S is set to the heap. Yeah, it's a register.
Oh, here. Heap address S. Yeah, but what does that? What is that holding? What is the semantics?
It's literally just a register, apparently.
There's no difference. It could be any
Like
letter.
it's mode is set by get structure fvnxi as follows. If the dereferenced value is an unbound ref cell, then it is bound to a new str cell pointing to the thing pushed onto the heap, and the mode set to write. Otherwise, if it is an str cell pointing to a functor f of n, then the register S is set to the heap address following that functor cells, and mode is set to read.
Okay. Okay. So there's nothing special there. Okay, so let's just retrieve the stuff. So what do we need? We need the store. Uh, we need the store. We need the registers for the first time. No, second time or something. We need the H register, and we also need the S register, and we also need the mode. Uh, and this is kind of ugly, not gonna lie. Boom. Then that, then computer. And let's freaking go. So
And
match
Nathan, yeah,
mode.
before Nathan left, he wrote, Lemos writes expressions on pure feeling and then goes into debugging precedence. And
Well,
that's why I prefer Lisps. You don't have to bother with precedence rules because they don't exist.
well, I would say that once you are in a language deep enough, you don't, it's gonna be natural to you. So like when I was doing Haskell more consistently, precedence was not a problem to me at all. Only in a few scenarios in which I was 100% breaking the natural precedence of the operators that mattered, but no. But I agree, not having to think about it is great in Lisps. I agree on that. So if it's a read, what should we do? What should we do? I think we can return the computer already.
Yes, we can. We just say,
Oh no, that's not correct. Oh no, wait, that is correct because regardless of the case, we're gonna increase the S register. So
yep.
let's do with here, and let's say that's gonna be ugly as hell, man. Let's do a let because I just noticed that what we are doing is changing a register inside the bank of registers. So registers.
But that's not a register in the same sense that the X registers, which are numbered, are. This is a dedicated register, like age.
What? This?
No, no, S. The
No.
one at the end.
No, yes, but that's not what I was talking about.
Oh, okay.
I'm talking about this thing. And what are we gonna add in there? We're gonna do.
Nathan asked, what's this project? It's Karuta, which is a logic programming language. And we are basing this on this book about Warren's abstract machine, which is what the name means. Oh, Karuta is the Japanese word. Actually, it's a Portuguese loan word in Japanese that literally just means card, as in playing cards.
Yeah. So store S register in, then value on that, and then we return the computer. Computer with uh, and think, I think I just need to say registers. Pragmatic machine. Cool. So now we're going to go to. Oh, this is also incorrect because I need to say that s register is equal to. Well, we can also do the thing that we did up there. That's fine. S register in, and there's that, and then we're gonna have write. And I'm gonna say something. It's been a while since I wrote, like I code functional stuff outside of Clojure. So this is really, really the feeling is great. I can recommend you to drive next session, Marin.
Uh,
So let's pick the heap and let's say heap put. We're gonna pick a value which it should be great if we created before. So reference as register in reference store in uh, wait, what is this? Oh, I need to pick the thing. I need to pick the thing, and this is h register. Awesome. Then we're gonna do a very similar operation to this thing, but the index of register, but instead of value is gonna be reference. And then we're gonna do computer with computer with um, uh, store store registers and h register thing. And we also need to do this type of thing. Is register and boom. Okay, the function is done. Do you see any problems, Mani?
let's see. Read, blah blah blah. We just set the. We just dereference a thing from the heap, and yeah, we get the the s register, and then we update. And then in write mode, we write a reference to the store. We also write it to the register. And then we bump the age pointer and the s pointer, oh, the age register and the s register will be bumped no matter what. So yeah, that looks correct actually.
Okay, okay, that's pretty awesome. Pretty freaking awesome. So unify value. Unify value. What should we receive? We should receive the same thing as the unify variable thing. Okay, but let's go over what this function is supposed to do. Do you know, Marinho?
Well, it's
Unify
supposed to
variable.
yeah, it's supposed to unify a variable. Specifically, it's supposed to unify a variable that is being introduced right now.
A variable that is being introduced. How are we introducing it? Using the register?
Well, yes, because if you go back to the three cases,
Three cases.
um, yeah, remember, case one is when a register is associated with a structure functor, which is get structure.
Wait,
Case two is a
wait, wait,
first
wait.
thing register argument, that is It's a register that we're allocating that has not been used before.
Oh, wait. So unify variable in read mode is just putting whatever S register is pointing into the register.
Yes, because it's a new register.
And an already seen register argument means.
Is the third instruction unify value instead of unify variable?
Wait, unify value is gonna do the unification thing.
Yes, because you have a register that already has something, and now you need to unify that something with something else, you see?
So then it's gonna go the algorithm of the. I remember that. I remember that. Remember that I was talking to you about logic programming doing my master's last year? It was this thing.
I see.
Cool. Cool. So let's do a match on the mode. So we're gonna need another function that is not yet written, which is unify. Pretty cool. Pretty goddamn cool. Not gonna lie. So we're gonna call a unify function, and we're gonna pass the index of the register, and we're gonna pass the entire computer to it. Actually, that's a good question. Does the unify function needs the entire computer? The answer the answer is no. It just needs the S register in here. I'm gonna assume. But we're doing push stuff. So yeah, I'm gonna send the entire computer. I don't care. Because doing push uses the memory. And well, it is what it is. Okay, so this function doesn't exist yet. So unify. So how are we calling that in here? So there is an A1, which is an address, and there's an A2, which is actually we don't have an A2. We have a computer. We're gonna return a new computer. Fail with unify is not yet implemented. Cool. Let's do also some things like these. Okay. So then I'm doing that, and then write. What should we do in the write case? We should
Mm.
write into the memory. So we pick the contents of out of the register, basically. So register value. We're gonna do find, and this is not the first time we use those. So let's copy value of register. Cool. That's exactly what we need. And we're gonna use h. And we're not gonna use the memory. Oh no, we will use the memory. And that makes sense. So let's pick the new store and say that this is a heap. Put the value that we're looking for is the value of the register, and we're gonna do that in the h register position, and we're gonna use the previous store. Cool. So now let's build a new computer with store with a new store, and we also need to have the new thing h register, and that's it, right, money? Oh, you also need to do the thingy.
The thingy.
Yeah. So this thing, I didn't notice that we need to do that here as well. Which means that this unify kind of sucks. But I can do, actually. Um,
Oh, unify actually takes just. Huh.
and I'm guessing this will indeed need fucking parentheses. Oops. And there is that. I think we're good to go. I think we're good to go.
Okay.
So what do you want to do now? Do you want to read the rest of the text or do you want to jump straight up to Unify?
Uh, I'm not sure actually. Let me double check. Unify variable.
We must also explicate. Is that how you pronounce that?
Explain.
But am I blind?
I mean, it kind of means the same thing that, as explain. Is
No,
just
the meaning
they
is very
chose
clear.
they chose Latin for some reason.
The unify operation used in the matching phase in read mode. It is a unification algorithm based on this thing, where variable substitutions are built, applied, and composed through dereference pointers. In M0 and in all later machines that will be considered here, this unification operation is performed on a pair of store addresses. It uses a global dynamic structure, an array of stored addresses, as an unification stack. Oh, so there is another stack specifically for unification.
Yeah, there's like 4 memory regions, and they all get treated as stacks at some point.
I understand. I understand. I very understand. Okay, but that we are kind of getting a little dirty here because in all of the operations, bro, we're gonna have to check off the sizes of those things. So the heap has a different size, and I was assuming that the heap would start at 0 in the store,
Uh, I
but
mean,
like
you just need to know where each region starts, right?
yeah, but that's the thing. That's kind of annoying as fuck. That's kind of very annoying. Like, and the question now becomes, can't we convert this module to a store module and make smaller modules for heap and PLD and whatever the fuck that we can abstract away all of these checks in the module?
Let me think for a second. We could, but we may not have to actually.
What do you mean? We already have three different understandings of the memory. We have store, heap, and now this thing.
No, no, no. There's one memory. It has several
No,
regions.
that's what I
The heap
said.
is
It's different understanding, which translates into different regions in this case. But we have different names because they mean different things, right?
yes.
So we already have to deal with three different understandings. And doing that every time on these functions that are using heap and store separately with different names, but they are the same thing. I think it's gonna suck like ass later on because we're gonna have to do the checks, man. We're gonna have to check if the heap thing is like respecting the heap size, you know.
Do we strictly have to do that though?
No, we're gonna have at least to save an index on where the PDL starts. You know what I'm saying?
Yes.
So I would like that we don't have to deal with this nonsense in the level of the computer. And I'm proposing to think if it's possible to migrate this dependency to, instead of heap, we call this store. And the store module handles all that stuff for us in a single place.
I guess we can do that.
But here's the thing that I'm not 100% sure how to do it. No, I do know how to do it. Interesting. So how should we do that? So we're gonna call this a store, and everything down there is broken, and that's okay. So now the question becomes, how should we model these things? Should we make a module inside a module here, and just say module heap struct and how is the relationship between the store and the heap? Does it involve functors? No, I don't think so, right, Marie?
No, the store is just your memory, the
We
entire
need,
memory,
we are
and the
trying
heap
to do
is a
mutability,
segment.
basically. So, Nathan, here's the thing. There is some memory, right? So imagine that this is memory, and the beginning is here, and until this point, everything is heap, right? And from here onwards until this part, everything is something is PDL, right? But the problem is that if you say PDL 0, like PDL this, you are actually referencing this cell.
No, that's not quite it. Like, just use three arrays. No, the thing is, we could use arrays, but we didn't want to go with mutability, Nathan. That's kind of why we're using a finger tree.
And
But
now
like when
I
you
am
say,
also, sorry to interrupt you, Marinho, but now I am also confused again. Because you said that this is not going to reference this cell.
no, 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 that's not it. When you say PDL square bracket something, you're basically saying, I'm dereferencing this address in the store, but it must be inside of the PDL, wherever that happens to live.
So that's exactly what I said. So this, in quote unquote physical memory, will be this cell.
Yes, if that's zero, then that will be indeed that cell.
So yeah, that's the problem. Explain me about the tree. Well, finger trees. It's a data structure that Marinho loves, and it works for our purposes. That's everything that matters.
It's basically a general purpose sequence. You can add and remove elements from both ends in constant time, amortized, and you can efficiently concatenate and slice and do random access as well.
He's not getting the problem, so I'm gonna try to rephrase the problem. The problem is that we want to have a single store. So this is a single sequence, very efficient sequence using finger trees. However, we would like to be able to reference the the heap and the PDL, which are subsections of the store, more conveniently. And what does that mean? That means
But
that these thresholds here that I put it arbitrarily here, I don't want them being passed around inside the computer, which is the computer, right? So there's registers, there's modes, there's fail booleans, there's all of that. And I
basically, you just want to have bounce checking, helpers that do the bounce checking for you. So you don't have
yes,
to do it all the
yes,
time
yes,
everywhere.
yeah, and I would like types parse. What? That doesn't make sense. That doesn't make sense. So so do
We
you
can't
have a
use
suggestion?
the thing is that if we use multiple collections to model this, we have a problem because we the address space we only have one address space, right? But if we break the memory up into actual different collections, then we have the problem of, okay, now the same address can mean different things depending on which
Exactly.
piece of memory you are looking at, right?
Exactly. Exactly. Wait. Wait a moment. Okay, so this is a functor actually. Because think of this, Marinho. All of these functions, push, pop, top, get, put, initialize, all of these functions, they are the same for all three of them. The store, the heap, and the PDL. right? However, the two of them, they have implementations that do checks for boundaries, which is the heap and the PDL. And we can embed the size for now as a constant inside them.
But you can't really do that. You need to embed the starting point of the heap and the PDL, but the size may vary actually.
That doesn't make sense. The indexing on where there starts that determines their size. So
No, it doesn't actually. It only determines their size if you know the size of everything afterwards as well. And it
no,
only
actually I
determines
said
the
the
max.
opposite. This defines the letter boundary. So this is like this position means that this is the size of the heap. That's what I meant to say.
Oh, okay.
And these, but that's
But that's
that's the
just the
catch.
no.
This
But
needs
that's
to
the
subtract
maximum.
this.
That's the maximum size, Lemus. Not the you're not necessarily going to use the entire heap all the time.
No, yes, that's the maximum size, but that's what we are already doing before, remember? When we implemented the heap, we made an initialize function, which is basically populating until the max size. In terms of constraints you want to enforce and flaws of your current modeling. Man, I think Buddy, you need to help me, man. uh, I don't know how to explain differently.
We want to have bounce checking. That's the short version.
Yeah, we want to have bounce checking on pieces of data that are sharing the same memory. So again, we have a store. The store is the entirety of the memory, so it's this thing. Okay? But from here to here, this is the heap. And from here to here, this is the PDL. How can we do the bounce checking and do the indexing very naturally without having to do all of this complexity inside the computer? I want it to be inside this module, the store module.
Uh, well, you should probably. Yeah, that should be a functor
That
actually.
should be a functor, right? That makes sense.
But we are parameterizing not the implementation of the operations necessarily. We're parameterizing over the sizes of the memory regions.
Yes, that is also correct. So I think we're gonna have to make a memory functor, right?
Uh,
Does that make sense to you, Marin?
yes, that basically describes the memory layout of the
Yeah,
of
the problem with the functor is that I don't know how that solves the problem of that being a unified piece of memory.
well, you define a signature that contains the maximum heap size, the maximum PDL size. They are just a bunch of integers.
Yes.
And then you make that signature be a parameter of a functor that constructs a store struct with the sizes that you gave as an argument. Um, it will need to use the sizes of the module that you gave it as an argument to compute the total size of the memory and to do all the bounce checking correctly.
Okay. Okay. So that's very exciting because that really sounds like a functor thing. Okay. So I actually propose to remove the store from this file. I actually propose that. Let's actually make a store.ml. And if you're gonna have signatures, I think one of the ways that we should try to explore is to have the MLI thing. Okay. So let's remove the stuff from here. Let's remove the stuff from here. I have no recollection of signatures and functors in OCaml. I actually think I never wrote a functor in OCaml. I only wrote them in a separate thing. Okay, so Nathan, help me here, please. Which of these two parts should live inside the MLI file? This one? Hello? Hello? One sec. Um, you just need the inner things. So we're talking about these things. Okay. So here it is. Here it is. So there's a type T there. Not declaring the module signature as that the file. Oh, okay. So this is okay. I see. I see. I see. I see. Okay. So what are the things? What are the things? Uh, so first things first. This, I think this is the type actually. This is the type. And then we need, Marinho, according to what you said, in the signature we describe the memory layout, right?
Let's see.
So something like store size, which is going to be of type um, A,
Store
heap
MLI,
size, oops,
but
and the PDL size.
but here's the thing. If we want those sizes to be parameters, this should be actually a separate signature, in fact.
A separate signature.
Yes, because if we want to make store be a functor, right, with the sizes as parameters, then
Okay,
the sizes are not really part of the store yet. They are a separate thing that the store takes as an argument to construct its result.
I don't know if I follow what you said, and I'm sorry about that. I'm sorry. But let's, for now at least, let's just do what Nathan said. Let's just do, first let's do everything, and then let's extract the signature out of the thing later on, okay?
Okay.
So this is everything that we have for this store thing. So let's just copy that over. So this can go away, and then we can do something like that. So what is the problem? I don't understand the problem. What is the problem? Dune build. Oh, the store
Uh,
file is not being recognized. I understand.
you need to
So
add it to Dune.
store, is this done? No, no, I need to run an X build at some point. But that's okay. That is actually very okay. Uh, okay, so what are we missing? What are we missing aside from those things?
Mm,
What do we need
what are
else aside from what is already here? Store being a
well?
functor.
Yes, store is not a functor yet. It's a module, right?
Okay, so I need to put the functor thing here then. Here. And I'm gonna say that store, it is a functor that receives what?
Well, it needs to receive a signature, a module with a signature, and the signature is just
Layout or something.
yeah, it needs to get a layout as a parameter, and we need to define that, of course. But
Yes. And what should be the return of that? Returns a module with signature set s.
well, the signature would be module. Well, just S, I guess. You need to define the signature like
What?
yeah, you need to define the signature as part of the store. module, I guess.
Oh, okay, so I also need to define that myself. I understand. So how do I make a signature thing? Is that the same syntax as in OCaml? Oh, SML?
If it's not, it should be similar at least.
Yeah, this thing. This thing. Okay, so let's
A
define the
layout.
store. A layout first. Let's start with the layout. That's not how you do that. Okay, so what are the things that you need to provide in the layout?
You need to provide the heap size, the PDL size, and maybe we need to add more things later, but we don't know about those yet.
Okay. Another question though. So let's call this T.
We don't need to define a type though.
That's well, but how are we gonna say that you need to provide the constants?
We say val, and then we say the name of the constant, and then its type.
Yeah, but are we gonna lock it into integers?
No, no, colon integer, colon int or whatever.
Yeah, we're gonna lock it then. I was kind of thinking of allowing it to be a.
But we need a numeric type.
That is fair. Then we're gonna have the PDL, and then we're gonna have a store, which is the total.
Do
Oh,
we want that actually?
what?
Because the total size of the store is just the sum of the total sizes of the parts, right?
That is not true. Because otherwise there's no memory to play around with, like making your program or whatever.
But the program will live in the areas, the predefined areas already.
Oh, so our memory as implementers of the language, we only live in the heap and the PDL.
I think there are a couple more segments that the book hasn't gotten into yet, but basically, yes.
Okay, so let's just have two for now.
And those should be max sizes, not actual sizes, because as I said, the actual usage of those areas will make their size vary
Okay,
as the program
okay, so we
executes.
made that. What is the next step?
And then the store uh, needs to take the layout as a parameter, which
Mm-hmm.
it already is,
Mm-hmm.
and then it needs to, well, instantiate a module using the constants from the layout that it got as an input.
Yeah, but I'm not getting how I should do that.
Well, you need to say struct, and then you have to put the definitions in there, and then you say and it's like
No, but I'm talking about line 7. What should I put in line 7? Because this
line
is wrong.
7.
This S should not be there.
Well, that's because the letter S is not actually defined yet.
Is this what you were talking about, Nathan? Equals? Equals something something? Equals something something. You need the S. It's the return. You didn't define it. I need the S.
Oh, right, you need
Don't
to
put a
define the
stick.
actual structure type that the functor will return as well. Like, you need to define the return signature, not just the input signature.
Oh, it is these things, right? It is pop, push, get, whatever.
Yes, but I'm not sure. I'm not sure if we should inline all of those implementations in the signature though.
No, that's not how you do that. You're gonna. This is only signature stuff. Take a look at stdlib with set. One moment, please. Yeah, we're gonna do this. You see?
Yeah.
But we're gonna do with our stuff. So first things first. I think we need an A here. And then we're gonna do push, and then the signatures of these guys, which I have no recollection of what they are. Do you remember?
Well, they take it.
Is this the signature of that?
Yeah, that's for push. Although here's the problem: push as it stands will not quite work directly because here's the thing: we're now making the memories a single contiguous thing, right?
Yes.
If we push, we're going to add stuff to the end of the memory. We're growing the actual physical memory of the hardware at runtime, potentially.
We can
Oh
think
wait, no,
about that later.
we're using push to initialize it though, aren't we?
We are using push to initialize it, yes.
Oh, in that case, it's probably fine then.
Okay, so val get, which I also don't remember what is the syntax. Well, not the syntax, the thing.
It takes the type, it takes the finger tree and an index, and returns an element. It should return an optional actually, but right now it doesn't.
Well, we can actually implement that now, more easily, I mean. I'm even gonna put it to do.
Okay.
Make this get safe. Okay, so then all of these guys go. Then we're gonna have a put, which will receive an a, an int, this thing, and return another thing, like that, which is cool. We also need to provide an empty, which is this, and you also need to provide an initialize function, which this, 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 and we're gonna return you one of this, and that's it, right? That's kind of it.
Mm.
And then we do memory here. But that's still broken. Okay, that's not correct.
You shouldn't name the input memory if you also have a memory that you are returning, because that would be confusing.
I agree on that. And this needs to be capitalize. Uh,
Does it? I'm not sure
okay,
actually.
do we need to name that stuff? We do. Ah, fuck me. Where is the example here? Yeah, here. Like a function indicated by the arrow, the functor setMake, you return memory instead of memory t. Seems wrong. And you need the name, apparently. Wait, don't we need memory.s?
No, we don't.
Really?
Memory is already a signature.
Yeah, but the highlighting is saying that something is very wrong. Okay, I'm gonna just call lay. Yeah, it is wrong.
Unbound module memory.
But module types are not modules. Layout. Yeah, but you see what's saying here? Unbound module memory. Hint. There is a module type named memory, but module types are not modules.
Okay. Well, we can't do .t because that's not.
use equals and then do the rest. You mean this thing? And then complete the rest. Okay, so Nathan also said to check set in the thing,
The actual source code, not
the
the
actual source
docs.
code. Yeah, no, but I imagine that there was a way to um, set module set. Thank you very much. Can't I click and go to the source code?
If you click,
Uh,
you'll probably get sent to the documentation page, most likely.
ah, this syntax error. Now it is waiting for something in there. I see on VS Code. Go to definition on the GitHub. Where is the where is the GitHub? Uh, GitHub. Huh. Is this the one? Seems this seems to be the one. I understand. Uh, well, I would like to not have to look into all of these. Where's the functor, man? That's the thing that matters the most. Well, that's exactly where I am. Congrats. Um, yeah, but you see here, he is doing the thing.
Oh, I see. The thing that you called memory would be the S in this case.
Yes, yes, but he's doing type and he's doing equals.
No, 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 no.
He
That's
is.
like, oh, okay.
He is doing that.
And then there's the signature, which is very large.
Yeah, but the functor is not here. The functor.
It's on line 73. It's called make for some reason.
Oh, okay. So this is just syntax stuff. Crap. I see. Wait, there is a difference in syntax. You see? This one is using equals and struct and all that stuff. This one is not doing that.
That's because that's just the signature of the module. It's not actually an implementation of the module.
Oh, so this is what we're gonna put in the MLI file later. That makes sense, actually. Okay, so this thing, let's nuke that. Let's also nuke this and just say this thing. Awesome, awesome. So now, what do we do? Now we grab these things and put it in there, right? Boom. Now what do we need to do?
Hmm.
Now what do we need to do?
We need to do some magic. Not really, but
We
it
need to
would
do
be
some
funny.
magic.
It would be funny if that was the case.
Wait a moment. Wait a moment. Let me try. And again, this is just because I'm not experienced with modules that extensively. I have a very dumb question. So we are creating this module, right? And we have access to this stuff that we are receiving. So we have access to these two variables.
You need to
But we
open
need to
them.
export functions of implementations of these guys.
Yes,
I understand. So for instance, this guy is already this guy, right?
right.
Okay. But that's still not what I want though. Like, we need to have in the memory layout something to do heap and PDL stuff.
We need to add those functions like get heap, put heap, and then those functions are basically get and put but with bounce checking.
Oh, so that sucks, man. I wanted to do heap.get, like store.heap.get. But you're saying that you're gonna do store.getHeap, right?
I mean, that might be doable. It's just I'm not sure
That's success, man.
why.
Because it's so much better to not have to do the get, like to pollute the names of the things and use the modules. You will make heap store equals to this. This is not what we want. Matan didn't understand the problem, man. Fuck. This is not what we want, Nathan. We want a single piece of memory. You don't want to make three stores. There is only one store.
Yeah, otherwise if you get an address, you don't know which store it's supposed to belong to just in isolation, you know?
Yeah,
That complicates things.
that complicates things a lot. Okay, so your proposal, Marinho, is to put a bunch of duplicated functions, both for the store, for the with different names. I mean, for the store, for the PDL, and for the heap.
That's an option. That's definitely an option. It's probably
Just create
the
more modules, nested modules. Yeah, but don't we need to put those the signatures of those modules in this thing? Sure. What? Am I going nuts?
hmm.
Okay, so my Nathan is saying like module then type heap equals, and then this also has a type T thing, right?
And it needs to be the same T that's on the. Does it though?
Of
Actually, do
course,
you need that?
man. This is getting so confusing. You are declaring a module type. You want a module value in that type. What? I don't understand. And I think the answer to your question is yes, Marinho. This T needs to be the same as this T. I hope that makes sense to you.
It does.
Look at the MLI for set. That's what Nathan said. Where is the set thing? Oh, here. Okay. Okay, so there is a module type. Then there is the module type S, which has a bunch of crap. Mm-hmm. Yeah, there's nothing. This is not. I am actually questioning if it's possible to do what we want, Marinho.
It might be, but it will be kinda convoluted.
No, yeah, but then we do it only once. That's the kind of the thing. It will be convoluted anyway. If we do it the naive way, it's gonna be convoluted and ugly. If we do it smarter, it will be convoluted but smarter. And as we get more used to it, it may be easier.
I thought you wanted to be a grug.
Well, it is also said in that post that Greg knows how to do complicated stuff. He just needs more time to digest it. Let me try that on the browser one sec. ChatGPT. Because that's actually a pretty cool exploration, you know? Because you are trying to identify if you can replicate mutability using the module system in a way.
We're not really replicating mutability, we just We just want to have bounce checking is the essence of what we're doing here.
I disagree with you. I think you are putting too much attention on the bounce checking, and I think it's more than just simple bounce checking. I think it's 100% because we want the thing to be a single tape. We could do three lists, we could do three finger trees, and then we just pass a predicate or whatever to check the bounce checking. That would be fine, right? Like piece of cake. My problem, with my understanding, the problem with my understanding is that we want to do that plus being a single tape.
We could make a single logical tape that is made up of three physical tapes, I
That makes
guess.
sense, but should we do that though? What is the benefit of having a single tape then?
Mm, well, fewer indirections, I guess.
Now, that is true. Inside the signature. Okay, so inside the signature, you just declare the heap module, this thing. You call that you use this thing, and then you say this. Okay, here's another problem, Nathan. The heap operations are also memory operations. So we just copy paste it like this. Is that the solution?
Ratinho. I'm back.
Hello.
Hello,
Um,
Magenta.
What is the difference between them? That's the thing. One is inside the other, but they are all memory.
what is going on here? Just create more modules, nested modules. Sure, not. That's it. Just nest them. Not quite it, I guess. You're declaring a module type. You want a module value with that module. Probably it was implementing something. Implementing a
Okay,
module.
okay, let's do the following. We already spent a lot of time on this. Let's explain to Mageta what was the idea. Then
Thinking of the that's a
we're
nice
gonna
AI voice.
discuss if we should proceed with this type of thing or not. So what was the problem?
Hmm.
The problem is that the book specifies that there is a single store of memory, so there's a single memory stick, but the memory is divided in sections, but they are one single piece. So you have the heap section. Now it introduced to us to do the unification the PDL section, pull
Uh-huh.
down list section. Marinho said that in the
Functional.
book later is going to be more sections.
Yeah, if I remember correctly from the original paper, I think there's like 3 or 4 sections of memory.
Yeah. And the problem is when you are referring to a specific section, it the indexing varies according to the section.
Mm-hmm.
No, the indexing is the same. It's just that you need
No,
to do a
it
bounce
is
check,
not the
right?
same. We already
It is.
went through this 3 times. I'm gonna draw it again here. So this is the memory stick. Okay. So let's
Okay.
say that the H is the delimiter, starting from 0, of course, starting from the beginning, from the left. This is the delimiter of the heap section of the memory. And just for the sake of simplicity, I'm gonna put a P here, saying this is the PDL. So from here to here, this is the PDL section. Now, if I do this, which slot of memory am I referring to?
None, because that should fail the bounce check.
Okay, so now you change your answer for
Okay,
a
but
third time.
either way,
Like, that would be the memory cell 0, but that's not in the PDL, and that's what you asked for, so it will
No,
fail
that's
the
not
bounce
what I
check.
asked for. It is in the in
okay,
the
folks,
recording.
real. Okay, let's go back to Earth.
Uh,
Either way, the access should not matter at all to the program. You should just pass the indexing, right, which is the only thing that always gets used apparently, right?
no,
Yes, we always use
Although,
the physical addresses, apparently.
right. But the thing is that it's mutable, right? So you have an internal type that you need to change the implementation. So it's actually a functor, right, in that case.
No,
Like
yeah.
I'm talking about the heap.
No, yeah,
So
no, no,
if
but I need
it's
to
a
clarify.
PDL, if it's a linked list with a DOL implementation, like that
Yeah,
shouldn't matter too. So those are two modules that you should just compose together.
that's the thing. But let's backtrack a little bit because Marinho changed his answer for the third time, and I need to clarify what because now I am confused. So
Okay.
let's go for the final time. This is the same question I asked before, but again, a different answer. If I use PDL 0, you said now that this should fail. That's
I mean,
correct?
the way I understand it, if the book says PDL 0, it is implying that 0 is in the PDL. Uh, so it should succeed, but you purposely chose a layout where the PDL does not in fact start at 0. That's part of the heap.
I agree, but the difference is that the Marinho that gave the second answer said that
That's
PDL
either
0 would be this thing.
mm,
It is
then I
recorded.
misspoke. Then I misspoke in that case.
Okay, so it is not what I thought then. The indexing
No,
doesn't change according to
it's
the section.
it's literally written in the book. It says on page where is it? Where is it? No, that's way too far. Uh, Let me just do a store because
Okay, but while you check that, I'm gonna finish explaining what was the idea to Mageta. So Mageta, my understanding before was the following: we have a single tape, that's okay. The tape is divided into multiple sections, that's also okay. However, my understanding was that you could index specific sections of the memory, assuming that this was like this is PDL, this what is highlighted, so 0 should be here.
yeah, it's on page 16 and 17, the last paragraph of 16 and first of 17.
Okay, I will check that shortly. And then I was talking to Marinho. Marinho, it's gonna suck ass very hard if every time we need to do a query on the memory, on the different sections of memory, we need on these functions, we need to check the boundaries. Like, oh, this is actually already outside of the heap. This is already outside of the PDL. And I was thinking, could we put those checks in a module and just here call them, and then everything would magically just be checked for us? Then it came the idea of making a functor, which is something, and that's what we were trying to do here, something that receives a memory layout, which is specifying the sizes of the sections, and it returns to you uh, the implementations of functions that are doing the checks. The problem that, well, not the problem, what I asked Nathan then was, Nathan, but I would like to be able to do this type of thing. I would like to be able to
And
do that.
how is that any difference from store.getHeap or heap.get?
Because then I don't have to pollute the names with this thing. It's already a module that I can just use the LSP and stuff like that. So I asked Nathan if this was possible to do like a module, like a functor that has in the signature another nested module. So then we could have
And
sensible
then it's
names.
just nesting. That's not a functor, right?
No, the functor is this thing.
You can pass as a functor and still use it. You just need to define that it needs to have that as a contract, the get, somehow. So both are possible, I think. I just don't quite get what you want with the difference between the get outside and inside the heap.
Bounce checking, basically.
Yes, the implementations of the submodules, such as
Mm.
this or this, oops, they would use the layout that you provided in the functor thingy.
Okay.
Doing the uses of these functions, it would check, oh, are you extrapolating the size of the heap?
I see, because they are already on the implementation of the memory, right? I suppose.
Exactly, exactly. So that was the idea. Then I was talking to Marinho about, dude, how are we gonna do that? I don't know if it's worth to do that. It was all exploration. We implemented a bunch of shit. If you're asking if we just were here talking, no, we implemented all the functions. We were about to go to unification. We already implemented all the other ones.
But then unification introduces a new memory region, and that's where
Yes.
this
Yeah,
thing started.
exactly. And
Mhm.
then that's where the conversation started. And that's where we are. And then Nathan was just dumping a bunch of OCaml insights in the chat.
Optimalism.
And then we said, okay, but this let's try to make it a functor instead of having leaving the like simple store. And then we were trying to do that, and that's where we are at this moment. So then the question is,
Okay.
there is another way to do this, by the way, which is to nuke the idea of having a module and just do what Marin said, which is like heap get. And then you just copy paste all of these 3 times, one for the store, one for the PDL, and another one for the heap, and you add prefixes or suffixes or whatever.
That's very cringe.
I
Exactly.
think you actually would only need the put and get actually.
That's better, I would say.
Man,
That's
like
better.
whatever is faster for you guys to do,
Okay,
just get
the
over it,
the
and then we can
fastest,
refactor later.
yeah,
I wouldn't get.
the fastest is to just do the put and the get for the heap and the PDL, and that's it.
Yeah,
So
and those
heap,
would have the bounce check basically.
Yeah,
yes,
that's
and
something I can fix later or whatever, or we can do it in another
PDL,
session.
not PDF. Okay, so this is the signature. So all of these functions, let's make a, I don't know, what is the conventional camel? Do you put comments to separate things?
And then I
Like
don't put comments
store?
whatsoever.
Yeah, no, I know your style. I know. Store operations. These are heap,
I
and
mean, I would
these.
put comments on the MLI, not there.
No, that we are doing the ML first because Nathan said it's easier to put in the MLI later. And this is heap, and this is here. And I'm gonna pick this to do and put it in here. Okay, okay, okay. So let's go.
Yeah, that's still signature, so that's fine.
Okay, so now comes the implementation. And this error right here is because I didn't run Dune yet. So Dune doesn't know this file is a thing. Anyway, so now we just nuke this. The implementations of the store functions are already here. And the difference is that the new functions, the heap and the PDL functions, will use the bound checkings coming from the layout here. Okay, let's go. So heap. So what are the? Do you remember? Oh, it is in here. Thank God. Here. Okay,
Yeah,
Nata actually
Nathan.
wrote the code.
Yeah, man, Nathan did exactly what I was suggesting. But just keep doing what you're doing. We can do that later.
Okay, so this is what is this? I don't know. Mem index, and we're gonna return. This is a get, so this is gonna return the a there. Cool. Uh, so we need to check. There's an if, which I already forgot how to do in OCaml.
If thing, then else.
Oh, so it's
Literally
only
that.
then. Okay. No, because
Yes.
in Erlang I'm used to the true nonsense with the
Oh,
arrow and
no,
all
that's
that stuff.
bullshit. No, that's a different beast. That's just bullshit.
Okay, so we're gonna check if the index is uh, um, greater or equal to layout heap size. Then we fail with something.
Lemons
Uh,
with is greater than or equal to.
yeah, yeah. Marinho has a fetish about less than man.
No, I just prefer to use less than because then I know that if the values are in the order that they appear on the screen, the value will be true.
That is true.
Man, what?
Yeah, yeah. He even has a link for the explanation of
Oh
that
man,
stuff.
no. What the heck, man? I'm sorry.
I'm
I,
sorry.
man, I'm pretty sure that it's like the Boolean. If you explain, I might agree, but man,
uh, okay, so this is gonna be the PDL. PDL. Yeah, this boilerplate is kind of sucks. But okay.
Nathan, once you not repeat code, I actually enjoy seeing this. Oh, by the way, you did PDF get, not PDL.
Yeah, I keep getting confused.
By the way, the link that you mentioned is not about using less than or equal to. It's about whether the bounds of a range should be inclusive or exclusive
Ah,
of
that is
the.
true. That is true. My bad. My bad. That is correct. That is correct. So I need to do a put thing.
And in fact, it's this thing.
University of Texas.
lm int
Okay, I got it. It's from Dijkstra.
Yeah.
That explains everything.
this thing, and then if the index is out of the heap thing, we do that. Put.
It's basically just one page, Nathan, but the short version is you should use less than or equal to for the lower bound and less than for the upper bound, because then you can represent all possible sequences of natural numbers, all possible finite sequences, I should say, without going outside of the natural numbers. Because if you use less than for the lower bound and you want to include 0, you have to say -1 on the left side, right? That's not a natural number. And if you use less than or equal to for the upper bound as well as the lower bound, then you can't represent an empty sequence.
This argument will not be used in the function. What? How does that make
What's
any
that?
sense? What is this warning?
The this argument will not be used in a That's the name of the function. Let rec.
What?
Um, you did rec there, so it should be working.
I
Try
think
to
we need
run
to. I think we
Dune
need to
build
run Dune.
first.
Yeah.
Yeah, run
Wait.
Dune build.
Let's now put the things in the MLL file. So what things do I put? Just this?
Oh, Nathan said check parentheses. Let me see.
Check parentheses. What?
You're applying stuff. Isn't that the goal? To apply.
You're
One,
applying
two,
stuff.
three. 1, 2, 3. Yeah, he's applying. That's correct.
Do I need to put parentheses in here?
Unless it's a tuple, I don't think so. No, unless it's a tuple, I'm sure you don't.
Wait. What is the get here? Okay, let's run the fucking Dune Dune build. Okay, so unbound ft put.
Yeah, you may
Uh,
need to change some.
store. Store module store doesn't exist. What?
Yeah, you may need to change some Dune files around.
Did you make a new folder? Oh no,
No.
you didn't.
No, but this one is always this thing. And then this one I changed. I added the store. We have the ST, you have the evaluator, and you have the store.
I'm pretty sure you don't need to put all the files on Dune.
Well, in the template that we were using, we did have to. I might want to delete the MLL file, by the way. Okay, so let's delete that. Well,
Yeah.
let's check first. Okay.
Oh, nothing's exposed. That's one thing.
Delete file. Yes. Well, not delete not that anymore. That's fine.
Let's see, Magenta, you don't. I think that was the Dune, right? If you don't, you can export the whole lib. Yes, which is what we want, I think.
Yeah, but module store doesn't exist.
Uh,
It's complaining the Doom file. Is this a Nix bullshit? Let's see if it's a Nix
delete. Oh,
bullshit.
yeah. If you're building using Nix, probably.
It is Nix bullshit. Okay.
Why did they make that integrated with Git? I'll never understand.
Because then you have a trivial and convenient way to do the git restore in the log file because the flick got broken. But to me, that's a very weak argument to have to do git add to fix the Nix run.
You need an impure dependency for running something that, in theory, should have the dependencies inside of it. Like, that's. Yeah, that doesn't sound like a good argument to me.
Wait, okay. These things.
But there's a
Uh,
parameter for
yeah,
deciding.
now it is complaining that which is missing something. How do I check? There is a way to fix this error in Emacs. Help me, Mageta.
Well, let me see. What's that?
I want to open the buffer that is showing the error message because the part that matters is missing.
You want to open the buffer that
Yeah, you see the error message on the right there?
the module ft is an alias for module badfinger tree, which is missing.
Missing
Okay.
what? I think the error message is cut in the middle.
Oh, you think it's cut? Okay,
Yes.
so go to the
No,
your
it's
configuration. Not sure if it's cutting, but
no, it's
let's
literally
see.
saying the module ft is an alias for Batfinger tree, which is missing. The module is missing.
Yeah, it could be that, but we don't know if it's actually cutting. That's the.
Yeah, that's an Emacs quirk of these particular package
But wait,
frameworks.
let's understand. So you assign the module there.
We
So
are
you
already
should be able
doing
to use
this,
the
by the
module
way.
value.
We are already doing. Ah,
What did you have there?
I have no idea. So
Did you put
lm
something else? Maybe that
that
was it.
that. What is the problem here? Unbound value put. What? Oops. We don't have put. What was the implementation of that stuff? Oh, the put was using set. I see the problem. Okay, now what's the problem? Oh, the heap comes first. Okay, so
It's not
this
ft.put, it's just put because that's not.
and this and there. Okay, it works. It works, bros. It works. And why is it showing this to me?
Because it feels like it.
Emacs.
That's LDoc, actually.
Yeah, but why is not like getting out of my way?
Press Ctrl G.
That was a new behavior of Emacs, but okay.
That's LDoc, actually. I think you.
Okay, this is progress. Okay, now do we have this thing? So now the question becomes, do we need an MLI file or not? Should
No,
we?
man, you'd never need that. If you, for this case, you don't. Go back.
Okay, so now we go to the evaluator and now
Evaluator.
everything is broken. I'm gonna remove
Uh,
this thing
okay.
and then the heap stuff is now completely fucked. Um, it is completely fucked. So the first thing that I want to do is to replace a heap
Nathan is
with
right, by the way.
what? My please the OCaml gods.
It might be better than the signature files in F sharp that are literally useless. But
Okay,
yeah.
this didn't work. So people, we need to discover how to fix this thing.
Unbound module heap. What do you
Oh,
want
it
there?
is the thing. It is the thing that Nathan said before. Module store make, and now we need to pass the layout. Uh, how does that work? How do I
Um,
create the layout?
well,
I need to
I
create
don't
one of
know.
those.
Is it a module? It is module type.
So I need to create a struct, right? thingy. Module layout, and I think I need to say store layout struct end or something like that.
Uh, I isn't that already like defined somewhere?
No, yeah, no, it is not. Only the signature.
Oh, that's a module type. Okay.
Yeah, and then we replace the vowels with lets, and then let's
That's
put
not.
some numbers,
Yeah.
whatever here. So
It's
10,
not really.
10. And then my understanding is that we put layout here, but there is something wrong with the syntax.
Yeah. I don't. I go back one.
You could just make the struct inline, no?
Not the syntax, maybe. And what about what Marin said, inlining the struct? Is that a thing?
I mean, instead of giving it a name and passing the name struct as an
Just do
argument to the
equal
functor,
right away.
yeah, just do struct inside of the parentheses. Struct
Ah,
let,
Yeah. Yeah.
yeah.
so grabbing
Equal,
this thing,
the value
basically.
equals that.
This,
Uh. Yeah. Does
does
that
that
work?
work?
It should. It should infer.
The functor application
Um.
is U-typed. And
Functor
there you go,
application.
Emacs. Thank you very much.
Well, man, is the store dot make a thing? Like, can you go
Maybe
back
not.
there?
No,
Because
it's
I think
just
there's a problem.
it is actually just store.
It's store dot store, isn't it?
Yeah,
Oh, so
store
then
dot
we
store.
should replace this. Okay. Store, awesome.
Try to, yeah. Try to run Dune build again. I think it might, yeah, might need to.
Okay.
Okay,
Wait,
so
this
it
is this
worked.
Nick's nonsense?
Yeah, it could be.
Okay,
Yeah,
no.
You
it,
still need
it
to
worked.
rename the heap to store.
Yeah. So
Yeah,
now I should be able to replace heap with store. And let's see what Nick tells me. It works, bros. It
I
works.
mean, we don't know that yet. It just compiled.
No, 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 but I have faith. So LSP, restart, whatever. Ooh, it's
And
still complaining.
why is it still complaining?
And it created an MLI file.
Which is empty.
I think it's because of your Dune garbage.
Okay, but we don't know what the heck is going on with this, but it works. It works. Okay, okay. But I'm very sad. I want the LSP to, if I'm gonna use it, I think it should be working. Kinda
Yeah,
sad.
whatever. Like, just test to see if the
Store
rest
is a
works.
type. Uh,
How does the shadowing
Or
work, by
T.
the way?
Or T is a type. Yes, it should be at least.
look here, Nathan. Maybe this is gonna help you. This, there's
It's
this,
930. Yeah.
there's this. So what the heck? What the heck is
Yeah,
wrong?
but whatever. Can't you run this thing to see?
No, it works. It well, it compiled.
No, okay, but like I want to see running. Like, can't we run
And
a tiny program?
and I don't think we can. Right?
I
We
know we
don't have a
don't have the unification, but if
Yeah,
we
it
we
don't have
don't
a
works,
have
comp
yeah.
unification.
I don't think we have a compiler yet. We just have the instructions.
Yeah, we don't
Yeah,
have a
so we would
compiler
need
yet.
to make a batch of instructions in a series to test.
Yeah, but while you were away, we did get structure, we did unify variable, we did unify value, and then we went into the discussion of the thing. Magetta, don't ask such simple stuff of our friend.
Wait, what did I ask?
Can you run a program?
Oh, right. Makes sense. No, I'm sorry. I'm now a TDD guy. I build tests for everything, and then I don't worry. Okay, I just develop my program around the
Oh,
test,
we
and
actually
that's
don't
it.
need the finger tree. Well, do we need the finger tree here? I don't think we
Hopefully
did.
not.
No, we don't. Okay. Whew.
Omit this now.
think it's this. Ah, of course. Okay. Are we
It is
gonna
garbage, man. I'll fix that.
wait? The
But
store,
I
the
don't.
store thingy. It is reread. Yes. I hate when Emacs does this nonsense.
You can add to some. I mean, I can't complain. That saved my life,
No,
literally.
I like when it saves my life, but
But you can move that. You can put like on a directory. Uh, like you can say, oh, save all the temporary files to my temp directory.
yeah, that makes yeah. But like, what's the my git thing to delete this? It's the
Hey,
A.
hey, yeah.
Okay, bye. And then I revert the buffer and it's completely fucked. No.
No, no.
No.
Yeah, but add the untracked, kill the untracked file too.
Kill this.
I mean, you didn't need to, but yeah.
Okay, so add instructions. That's not instructions to compile program.
Let me pull the code.
Okay,
Let
but
me
now,
pull the code and not poo
okay,
on the
but here's the
code.
thing. So, Magetta, do you see this nonsense here?
Mm-hmm.
We would like to remove this boilerplate. But I don't know what's the best way to do it. The way that Marinho suggested is very okay. Like, oh, let's just put prefixes and suffixes and that's it. That works. And the evaluator is just missing. Man, why is my LSP fucked? Well, anyway, I'm gonna have to discover that. I'm gonna finish the recording now.